Equations, trigonometric types. Okay, so last year in year 11, I believe we solved trig equations. So something like this, tan of theta is 1 on root 3. These were the types you looked at. Solve that. So this was an example. Solve tan theta is 1 on root 3 for 0 less than theta less than or equal to 2 pi, for example. Do you remember what we did? There were 3 steps. I said there are 3 steps. Step 1, which quadrants or? Yes, all right. Yes, you can use the special triangle. So tan of what is root 3? So first, step 1 was your, that says step 1. It's your acute angle theta. So tan of what is 1 on root 3? Is it 30? Is it 60? Is it 45? Well, 1 on root 3 is the small one. So it's tan of 30. So what's 30 in terms of, so it is 30 degrees, but we're working with radians. So yeah, 30 is 180 on 6. So that's step 1 always. Find the acute angle. You say tan of what is 1 on root 3? Step 2 is to identify your quadrants. Tan of theta is positive. So we say tan theta is positive in quadrants 1 and 3. We draw our little diagram showing quadrants 1 and 3 with an acute angle of pi and 6. I know that that does not look like 30, but otherwise you can't see it. So step 1 is the acute angle. Step 2 is identify the quadrants. Step 3 is to do a sketch and answer the question. So therefore theta is, so what's this angle? Remember, you start from the positive direction of the x-axis. What's your first answer? Yeah, pi and 6. And remember, this is 0. What's this? 0, pi, 2 pi. So the first one's pi and 6, and the second one is pi plus pi and 6. Remember, positive angles go. So you're just counting. Normally it would be 180 plus that bit. It would normally be 210. 180 plus 30. So we go so this is, so you need to go like this. This is 0, that's pi. Isn't this pi and 2, 90? So we've got 0, 90, 180, 270 is 3 pi and 2, and back to 360 is 2 pi. So we go pi plus more. So we've got pi plus pi and 6. Now that's 1 and 1/6. What's 1 and 1/6 as a fraction? Yeah, it's 7 pi and 6. So that's how I work with pi's. That is 1 and 1/6, which is 7 on 6 pi. So that's that solution. Lem. Cos of theta is -1/2. You can do your quadrants first or your acute angle. It doesn't matter. Maybe let's do the quadrants. So which quadrants are we in? So cos is negative this time. So what quadrants? Quadrants. Remember, we've got all stations to central. Quadrants 2 and 3. So quadrants 2 and 3. So you can say cos theta is negative, all right, so cos theta is negative in quadrants 2 and 3. You can just write Q2 and 3. Then we need the acute angle. So the negative only tells me the quadrants. Then pretend the negative's not there. Cos of what is 1/2? Cos of 60, that's right. Then we say acute angle theta is 60, which is, but we're working in, I'm asking for this solution in, I'm going to ask for the solution like that, okay? And I'm also going to ask for the solution like this. I'm going to ask for the solution 2 ways. So you have to give me the solution from 0 to 2 pi, and then we're going to practice looking at the solution from -pi to pi, okay? So we've got quadrants 2 and 3. The acute angle is 60, which is 180 on 3, which is pi and 3. So you draw in quadrants 2 and 3. Remember last year we talked about the butterfly. The butterfly. So always your angle touches the x-axis in whichever quadrant you are in. Sorry, you can't see that. So that angle, if it's in quadrant 1, it touches the x-axis in quadrant 1. If it's in quadrant 2, it touches the x-axis in quadrant 2, or quadrant 3 or 4. All right? So I've sketched it there. So what are your solutions? See, if this is 0 and this is pi, you're not quite at pi. It's pi short pi on 3. So it's pi minus pi on 3. You do it visually. And the other one is pi plus pi on 3. Can you see it? Yes. So pi minus pi on 3, pi plus pi on 3. Look, I always recommend that you draw it visually. You can learn the rules. Look, normally the rules are like this. 0, 180 minus theta, 180 plus theta for quadrant 3, and 360 minus. But now with radians, it becomes pi minus theta, pi plus, 2 pi minus. So they're your quadrants for your positive angles. All right, I'm going to do this one in a minute. I haven't done that one yet. All right, because I'm going from 0 to 2 pi and I'm looking for all my solutions. So 1 minus a third is 2/3, and 1 plus a third is 1 1/3, which is 4 pi on 3. Now that is if I give my solutions from 0 to 2 pi. I can also ask for my solutions instead of doing one full revolution, or if you want your solutions from negative pi to pi, I can ask you to give me the solutions that way as well. The diagram is identical, but it's just the way you read it at the end. Okay, so if you're asked from negative pi to pi, yes, we've got quadrant 2 and 3 again. Same question. I've got 0, pi on 2, pi. You have to go to there and stop. And remember, negative angles go clockwise. You've got to go from 0, negative pi on 2, negative pi coming backwards. Because remember, a circle is 2 pi. Pi forwards, and you have to stop. Then you've got to go pi backwards, and you've got to stop. Remember, negative angles are the opposite direction to what you would think. How are you going to remember? Quadrant 1's up here because everything's positive in quadrant 1, so you've got to go that way. For positive angles, negative angles go the other way. All right, now I better draw that again because people will forget it. So, they're my positive angles. So these are my positive angles. They go this way, positive. They're the positive angles. They go anti-clockwise. Now the negative angles go a different way, the opposite way. Your negative angles go like this. They're your negative angles. Now, you know how with positive angles you've got 0, 180 minus pi, 180 plus, 360 minus? Yes, no? All right, with the negative, I'll draw the butterfly, it might help. If your theta is here, 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 or here, how do you name those angles? What would the first one be? It's just negative pi. So in this quadrant, the way you would name this angle here as a negative would be negative pi. What's this? It's negative pi, but I didn't make it there. It's negative pi, come back for positive theta. Negative pi plus theta. Look, if that was 30, wouldn't you say this is minus 150? Yes? If you have to go all the way to there, it's negative pi, and I'm still going in the same direction. Negative pi minus theta is this one. It's better to do it with numbers in a minute, right? And if I want to get all the way round to this angle, so this is how you name negative angles. You've got 0, negative 90, negative 180, negative 270. So going clockwise, this would be negative 360. So you go negative theta, negative pi plus, I'm coming back in the positive direction for theta. The next, how do I get to that line? It's negative pi, and I'm still going in the negative direction, so it's negative pi minus theta. And the last one is negative 2 pi, come back for plus theta. Now, that might seem, I'll do it with numbers in a minute, all right? I want you to look at the two diagrams. All they are, see how I've got 0, pi minus theta, pi plus theta, 2 pi minus. This second diagram, you just subtract 2 pi from each of the numbers in the top diagram. So this angle, that's theta. So this quadrant is theta. If I subtract 2 pi from it, I get negative 2 pi plus theta. This is pi minus theta. If I subtract 2 pi from it, I get negative pi and the minus theta stays. No. All right. So how do I answer this? So I have to go from 0 to pi for my first answer and stop. And then I've got to go from 0 to negative pi for my second answer. What are my two answers? So going in the positive direction, what's this angle? Yeah, it's pi, but I'm short pi and 3. Now, I have to stop there because you're going from 0 to pi and you stop. Then I come back this way. How big's that angle? Yeah, it's actually negative 2/3 pi. Or you write it as negative pi plus pi and 3. Now, if you want to write it like that, I go all the way to negative 2 pi, but I come back for pi and 3. But I prefer to say, well, if that's 1/3, this is 2/3, and it's in the negative direction. It's actually, so you don't have to use all this. The only time you would use this is for a really hard question where they're just giving you no numbers and just thetas and pi's, and it was towards the end of the paper or something. So you can just look at this and say, if that's 1/3, that's negative 2/3. And if that's 1/3, that's positive 2/3 if I'm going this way. So it's just 2 pi and 3, negative 2 pi and 3. What happens if I asked you for the answer this way? Give me the answer from negative 2 pi. If I want them all as negative answers, how would you answer this? Same question. How do I do those from 0 to negative 2 pi? What would my answers be? Negative this one. So this one, yeah, is negative 2/3 pi. So I would look at it and say that's 1/3. This is 2/3. So it's negative 2/3 pi. And or it's negative pi and it's basically negative 1 1/3. Can you see that? So it's negative 4 pi and 3, or if you want to spell it out, that one is negative pi minus pi and 3. Look, I prefer that you go, that's negative 1 pi and another third. It's 1 1/3 around. It's much easier. Do you see it as 1 1/3? Negative pi and another third pi, that's 1 1/3. All right, so you could be asked answers from negative pi to pi, from all negative angles, from negative 2 pi to 0, and it's just the way you go around the circle and read off the numbers. All right, now we're going to be doing a lot of this in this exercise because they want double angles. Look at my finger. Solve the following. Cos of 3x is 1. You don't do this normal method because whenever you're asked to solve sine or cos is 0, 1, or negative 1, you sketch it. So this one is best to sketch, only because I'm asking you to solve cos of either 0, 1, or negative 1. Because if I draw a normal cos curve, it looks like this. But that's cos x, that's not cos of 3x. How do I sketch that curve? And the other thing I need to look at, I'm solving that for 0 less than or equal to x less than or equal to 2 pi. So, but the problem here is I'm solving cos of 3x. So the first thing I've got to do is my domain originally was this, but because I'm solving for 3x, what do you think I'm going to do to everything? Multiply them all. I'm not solving for x, I'm solving for 3x. So I've got to, how am I going to go from x to 3x? I've got to multiply by 3. So I do 0 times 3 is 0, x times 3 is 3x, 2 pi times 3 is 6 pi. You actually have to solve this from 0 to 6 pi when you're working with 3x. Okay, so this is a normal curve, right? A normal cos curve, a normal one, which finishes at 2 pi and pi is halfway between, yes? So we know cos of what is 1, girls? Cos of what? Look at this is a normal cos curve. Yeah, good. So cos of 0, this is y equals cos theta or cos x. whatever. This is a normal cos curve. It's not that cos 3x curve. I've just drawn a normal cos curve. I know that cos of 0 is 1, and I know that cos of 2 pi or 360 is 1. Okay? Now, if we're going to follow the steps of what we did before, okay, cos of what is 1? What's my acute angle? Acute angle. Remember, first step, acute angle and then quadrants, all right? But this is tricky because it's on the border. Step 1, the method, acute angle theta, but it's acute angle 3x because I'm doing cos of what is 1. Got it? See, in the other questions, I did, if I can find them, what did I do? Cos of what is 1? Look, acute angle. Cos of 0, that's the acute angle. I don't want the 2 pi. So acute angle, not x, but acute angle 3x. If I was just looking at that, that 3x is 0. So my acute angle 3x is 0. Now, is cos positive or negative? So cos is positive in which quadrants? In quadrants 1 and 4. So what are my solutions? So 3x is, quadrant 1 is the 0, and quadrant 4, isn't that 2 pi minus? 2 pi minus 0 is 2 pi. Now, but the problem is, you're solving x from 0 to 2 pi. I have to solve 3x from 0 to 6 pi. So I've got to keep doing more solutions. Where's my next solution going to happen? Where? Well, I've got a solution at 0, 2 pi. Which one? Good. Do I keep going? And 6 pi. But those are the solutions for 3x. I need the solution for x because the question is solve for x lying between 0 and 2 pi. So if 3x is all of those solutions, how do you go from 3x to x? You divide by 3. So I've got 0, keep going, 2 pi and 3, 4 pi and 3, 6 pi and 3 is 2 pi. The other option was to sketch the curve cos 3x, but you know what, you would have had to have done all these fractions to do it. That was the other way. I can show it to you. If I decide to sketch cos 3x, you do a cos curve. Instead of it being 2 pi, so the other way was to sketch y equals cos 3x. Actually, it wouldn't have been so bad. So what do you get? What's your period? 2 pi on 3. So I could have done this. 2 pi on 3. Another one would be another 2 pi on 3. See your solutions? Probably should have done this, shouldn't I? You could have done that. Yes, that's your other way to do it. But the only time you can do it this way is for cos x is 0, 1, or negative 1. That was the other thing, to actually sketch y equals cos 3x and read them off. Now, I'll do another one, and I'll show you why I showed you that method. Because for a question like this, so another question 1 type, but I'm not going to do the same one. Let's ask you to solve tan of 2x equals 1 for 0 less than or equal to x less than or equal to 2 pi. So you could have done this question using this method, but the thing is, for something like tan of 2x is 1, you can only use that method. But for cos x or sin x is 0, 1, or negative 1, you can sketch, but you've got to sketch it properly. All right? Now, first thing you've got to do is they're asking you to solve this from 0 to 2 pi, but that's for x. I don't want just x. I need to do what? 2x. So you have to write my new domain is with a 2x. So what do I do to each of these values? Times them by 2. So instead of solving from 0 to 2 pi for x, I must solve from 0 to 4 pi when I'm talking about 2x. Don't worry, later we're going to divide everything by 2 and our answers will fit. Right? So same steps as before. So this is now step 1. Step 2, which is the old step 1. Acute angle 2x. Because I'm saying tan of that is 1. What's that? Tan of what is 1? Come on. Tan of 45, which is pi on 4. So the same step 1, I'll call it step 1. Don't worry. So first thing is domain. Fix it. I need to go from 0 to 4 pi. Back to the old step 1. Tan of the circle is 1. So you have to write 2x. Do you get it? Because the acute angle 2x, because tan of 45 is 1. What's the next step? The quadrants. Is tan positive or negative in this case? Actually, can we make this a negative 1, 1? Just put a negative. All right, just so that we can do a negative 1. So tan is negative in which quadrants? Quadrants 2 and 4. Good? So this is what we've got. We've got that the acute angle 2x. Do you understand why I'm writing 2x? Because tan of that is 1. You ignore the negative. Then we look at the negative. It tells us the quadrants. Now we write out our solutions. So 2x equals, you do a sketch, and your acute angle is pi on 4 in 2 and 4. And then you read them off. Now, let's start reading them off, right? Same first step, except you've got to write 2x. Same second step. Now read off your answers. What's that? Well, it's nearly pi, but we're short, how much? A quarter. So what's it going to be? 3/4. Don't sit there and learn all the formulas, pi minus this, pi plus that. I don't do that. I just draw it and I say I'm a quarter off. So isn't it 3/4? What's the next solution? I'm almost 2 pi around, but I'm almost 2 pi, but I'm short a quarter. What's 2 minus a quarter? 1 3/4, 7 pi and 4. But I have to go, when I'm working in terms of 2x, I have to do, how many revolutions is this? 2 revs of the circle. I have to go around twice. Gone around once, and I've got my 2 solutions, and then all you do to these, you just add 2 pi to each of them. So what's 2 and 3/4? Do you get it? So you just add 2 pi to each of those. So I go 2 pi plus 3/4 pi and 2 pi plus that. Now, so you got 3 pi on 4, 7 pi on 4. What's 2 and, isn't that just 2 and 3/4? 11. Yep. Now, can you see a pattern? What are you doing to the tops? You're adding 4. See, 3, 7, 11. Pretty sure. And that makes sense because 4 pi and you're short a quarter. See, 2 pi, you would have been 4 pi, but you're short a quarter. That's 3 3/4. See, because 4 pi is 16 on 4. 4 is 16 on 4, and you're short a quarter. Now, that's what 2x is. So as long as all your 2x's are lying between 0 and 4 pi, now I divide by 2, and I get 3 pi on 8. Just remember, 8ths are half of quarters. See how you're in quarters? You halve a quarter. Don't you get 8 pieces to your pizza? So you're dividing by 2. You're now in 8ths. Keep the numerator the same. All right?